Okay? All right. Day 2, they want to know what property took place. So if this is the original equation, this is the second equation. Hopefully you can see they rearranged and moved the 2x next to the 11x to the third. Okay? So it says which property is not used. Okay? So the first property is commutative. So we use the commutative. We pull out an x to the third. So that is the distributive property reversed. Okay? And this one is the commutative property of addition. This one is combined like terms. And then this one is distributive again. Well, let's see. This one is also associative. Okay? Because we multiplied this times that, right? To get that. So the only one we did not use was B. Commutative property of multiplication. We did not use the multiplication part. We only used addition. Okay? All right, questions on that? All right, so put that aside, and we are going to start lesson 13.1, which is on page 413. 413. Okay, so we are switching gears to our geometry. Okay, so we're going to explore nets and surface area. So it says make and use nets to find the surface area of rectangular and triangular prisms and pyramids. All right, so let's look at the first one. So this is considered to be a rectangular prism because a prism is a 3D object. So remember that, 3D. Caleb built a rectangular box to store his cast iron oven when camping. He wants to paint the outside of the box and has enough paint to cover an area of 14 square feet. Does Caleb have enough paint? All right, so the thing about a rectangle prism is you have to remember that we have several faces. So the front is the first face, right? And then we have a back that is the same dimensions as my front. Okay? So my front, if this is 2.5, we know that this is 2.5. And if this side is 1, right? We know that this is 1. So the dimensions of the face are a 2.5 by 1. So that's the front and the back of this face. Okay? Then we have a top and a bottom. So this is the top. And then, of course, that's sitting on the bottom that you can't see. Okay? The dimensions of that face, which would be this right here, would be a 2.5 and a 1.5. So 2.5 by 1.5. All right, and then we have the side. This side right here, and then we have this side that you can't see. So two sides. Okay, and the area of that face is a 1.5 by a 1. Okay, so when we find surface area, we basically find the area of each face. So we're going to take the area of each face and then add together. Okay? All right, so the area of this face, this one's easy, right? 2.5 times 1 is 2.5. Now, remember, we have a front and a back. So once we find the area of the face, we have to multiply it times 2. So this would be 5. Okay? So the area of this face, that would be 2.5 times 1.5. So that would be 25, right? 10 plus 2 would be 12. There's my placeholder. 1 times 5 is 5. 1 times 2 is 2. So 5, 7, 3. 2 decimal places, right? So 3.75 times 2. So that would give me 7.5. So the top and the bottom is a total of 7.5. So 5 plus 7.5. All right, and this one's easy as well. 1.5 times 1 is 1.5. We're going to multiply it by 2. So that gives me 3. So we're going to add them together. So I know 5 and 3 is 8. So 8.0 plus 7.5. And then 8 and 7 would be 15. So the area of the box, or the surface area of the box, is 15.5 feet squared. He only has how much paint? 14 square feet. So would he have enough?
Miss Lavelle?
Yeah.
Can you keep this up for a little bit?
Yep, I will. Okay, so he only has 14 feet squared of paint. We need 15.5. So that is not enough. All right, so let me zoom out so that you guys can see the whole paper and copy what you need.
Miss Lavelle?
Yes.
Can you, record?
I am recording it.
Okay, because I'm about to go into a vehicle and you guys are on my phone.
Okay. If it's a lesson, I always record the lessons.
Okay. But I'll be in on my phone for the rest of the meeting, so I'll just be listening.
Okay.
And yeah. Is that okay with you?
I'm sorry, what? Let me know when you're ready, Gia.
Okay. It's just that I didn't have the book with me at the time you started it, so I went to go get my book.
Okay, no problem.
Last minute, so I had to copy stuff down.
Okay, no problem. All right, somebody has a question. Let me see. I gotta see who the hand is. Clementine, you have a question?
Yes. I was confused on where you got the 2 from when you had to multiply it after you multiplied the front, the back,
Okay.
2 bottom and 2 sides.
Okay, so remember the 2.5 times 1 is just the front, right? That's the dimensions of the front. But don't I have the back as well that has the same dimensions?
Yes.
So that's where the 2 comes in. Because the 2.5 is just the front, and if the back has the same dimensions, I can just multiply it by 2, or I could have done 2.5 plus 2.5.
So, okay, that makes more sense.
Yeah, so it's just easier to say, let's multiply it by 2. Okay?
Okay, thank you.
Yep, so that's where it comes from.
Miss Lavelle,
Uh-huh.
I'm really confused with all of this because my Wi-Fi is like really bad, and whenever you were going through it, it was like going really fast, and you were breaking up, and it was like frozen, and then it would skip to all this work on the paper, and I was just so confused.
Okay, so the best thing that I can tell you is that later on this afternoon, I will upload the video. So my suggestion, if you're having video issues, is to re-watch it later on. I mean, I can re-explain it, but if you're continuing to have video issues, that would be my solution. Is I upload everything into YouTube, so you can either subscribe to my YouTube channel, right, where all the videos are, or I attach the video to the video tab on Teams. Do you know what I'm talking about?
Yes, ma'am.
Okay, so I attach everything on Teams. The problem is I can't upload the video until I get home because Duval County blocks it. So that's why I can't do it until later on tonight.
Okay.
Okay?
What's the channel?
It's YouTube. So I'll put the link in the video chat.
Okay.
Okay?
Thank you.
All right, so there's the link, Brianna, to the YouTube. And all the videos that I've ever done are there.
I got it. Thank you.
Okay, uh-huh.
Miss Lavelle, is that thing 1.5 or 115?
Where are you at? Right here?
The multiplication equation.
This one?
No, the one down by the addition one.
Oh, that's weird. It should be 1. It's this one. So it should be 2.5 times 1.5.
Okay, thank you.
All right, are you ready to move on? Not yet?
You can go now.
Okay, awesome. All right. So, the Turn and Talk says, if Caleb does not paint the bottom of the storage box, would he have enough paint? All right, so that means we've got to go back up here, right, and look at the top and bottom. So the area of the bottom or the top is 3.75. So we're going to take that 15.5 and we're going to subtract 3.75 because this is the area of the bottom. Okay? So 15.00 minus 3.75. So that gives me a 10, this gives me a 9, this gives me a 4.
Miss Lavelle, why did you put 0, 0 instead of 5?
Oh, you're right. I don't know. I don't know the answer to that question. I wrote it wrong. So this makes this not a 9, it makes it a what? A 14? So then that makes this a 7, not a 2. Sorry. This is why I don't use pens that don't erase. Alright, so if I subtract the bottom, now all I need is 11.75. So would I have enough paint? I have 14.
Oh, man.
I need 11.75.
You need 11.75, which means you don't have enough.
I have 14.
Sorry.
I only need 11.75.
You have enough.
Yeah, so yes would have enough. Okay? All right, we ready? All right.
Yes, ma'am.
So the next thing we are going to look at is what we call a net. So a net is an arrangement of two-dimensional figures that can be folded into a closed solid figure. Okay? So a solid figure is a three-dimensional figure because it has three dimensions: length, width, and height. So length, width, height. That's why it's considered to be 3D. Okay? A cube is a closed three-dimensional figure. Look at the cube at the right. How many faces does a cube have? So we have front, back, top, bottom, side, side. So how many faces do we have?
Exactly 6.
Yes. Okay? And it's the same as a rectangular prism. A rectangular prism has 6 faces. Okay? All right. A net is a pattern made when the surface of a closed three-dimensional figure is laid out flat, showing each face of the figure. Look at the two nets shown. What do you notice about the nets? What three-dimensional figures might they represent? All right, so I cut one out. Okay, and hopefully, guys, you can see that all of these look the same, right? They all look the same size. So that is considered to be a square prism, or we call it a cube. Okay? Hence the reason why a Rubik's cube is considered to be a cube. Even though there's 6 different colors, it is still the size of a cube. All right, so this is the net, right? This is the net. I just cut it out. So what I wanted to show you is that if I fold these pieces, right? So here's that. And I fold them, not all nets are going to create a three-dimensional figure. So if you notice this net right here, right, it looks like it would create a cube, but if I fold it together, this top part overlaps with a piece that is already there. So even though it looks like a cube, this net does not form a cube. Okay, so this one does not form a cube. But if I look at this one, which is this one right here, right? And I fold it. So I fold this one up, fold this one up, fold this side up. Now you can see that nothing overlaps, right? So it forms that nice cube. So this one is a cube. This one does not form a cube. So that's what C is asking you. Trace both of the nets, cut each one out, then fold the nets, which we did. Which net will fold into a closed three-dimensional figure? Which one will not? So the left is a cube. The right is not. Okay? So I just don't want you to be deceived about what will make a cube. Just because it looks like it has 6 faces does not necessarily mean it will be a cube. Okay? All right. So on a cube, write an equation to represent the area of one face. So an area of one face. So in a cube, we call them sides. We don't call them length and width. Okay? So the area of a face is either side times side or side squared.
Here's what I found.
All right. If the side is 4, what would the area of the face be? Well, it just means it's going to be 4 times 4. And 4 times 4 is 16. Yep. So the area of one face of a cube is 16 centimeters squared. Okay? The total area of the cube would be what?
16 times 6.
Yes, because I have 6 faces that are 16. And that would give me what? Well, 6 times 6 is 36, right? 1 times 6 is 6, plus 3 is...
96.
Yep. 96 centimeters squared. Okay? So area and surface area are always squared.
It's Lavelle.
Yes.
Can you go back to question B?
Yep.
Thank you.
Uh-huh. And I need to go open my door, so give me a second, guys. All right, let me know when you're ready.
Okay.
Yes.
And when, like, you do want us to turn in, like, if you do it on your own today, you said not to do, you said not to turn in the lesson, right?
Yeah, I don't really, I mean, you could, a lot of people who do it on Seesaw and submit it, but you don't have to turn in the lesson. No, only thing I want is the on your own and the bell ringers. That is it.
That's okay, thank you.
Yep, that is it. All right, so am I ready to move up? All right, so the turn and talk says, what do all 6 faces of the cube have in common? Is there another way to calculate the total area of the faces? Okay, so what they have in common is they all have the same area, right? So they all have the same area. Okay, so is there another way? So the only other way, and that's kind of what we did, right? We really did length, width, and height, because what we really did is we found the area of the base, because that was a 4x4, right? So it really isn't length, width, height. It's what it is length times the width times the face. No, times the amount of face. So we could do it that way, but that's the way we really did it, was we found the area of the face and then we multiplied by the amount of the face. Okay? And all 3D figures, I shouldn't say all, most of your 3D figures are going to have 6 faces. The only thing that's going to change that is a pyramid, because sometimes you'll have a square pyramid, sometimes you'll have a triangular pyramid. And then if we have like a pentagonal prism or a hexagonal prism, then the faces change a little bit. Okay? So that's the only time that it will change. All right, do I need to pause for a second? No? I don't hear.
Yeah.
This one has a name.
Yeah, and the other one says she just looks like
I'm done.
Okay, good. All right, so let's move on to the next one. All right, so now we're going to look at a pyramid. So pyramids, once again, depends on the bottom of how many faces you're going to have. Okay, so as you can see here, the bottom is a square base. So that means I'm going to have 4 faces on the side plus the bottom. So if I open this up, this is the net of that pyramid. Okay? So let's go back up top. It says, look at the square pyramid. How many faces does the pyramid have? Explain how you know. So we have 1 bottom and 4 sides. So this is a 5-sided figure. Okay, so it's a 5-sided figure. Yes, William.
You're glitching out really badly.
Okay, well, I don't know what to tell you. So the only thing same thing I told Brianna is you may have to watch the video later.
Okay.
Okay? It could be that you're also in the car, that it's causing your movement not to get good Wi-Fi. Alright. Alright, so let's look at the net. So this is the net. So what you're going to do is same thing we did for the prism. We're going to find the area of each face. Okay? So it says, what is the formula for a triangle? So area equals 1/2 base times height, or base times height divided by 2. Okay? Either one of those is fine. All right, so we're going to fill the dimensions in based on what was up here. So we know the square, right, the bottom was 5. And the only one that's pointing to the bottom is this one right here. So we know that is 5. We know the height is 7. So all of these are pointing to the height. So all of those are going to be 7. Okay? So C says, what is the area of one triangular face? So we know the base is 5. We know the height is 7. So 7 times 5 divided by 2. So 7 times 5 is 35. Divided by 2 is 17.5 inches squared. Okay, so that is the area of one face. Okay, the area of one face. All right, what is the area of the square? So side times side. So 5 times 5
5 times 5 is 25.
Yep. So the square is 25 inches squared. Okay. So it says, how can we find the surface area of the square pyramid? So we're going to have to add the area of each face. So if this is 17.5, this is 17.5, 17.5, 17.5, and this one is 25. So we're going to add.
Wait, which one is 25?
The square. The bottom. Okay, so add the area of each face. All right, so instead of adding 17.5 plus 17.5 plus 17.5 plus 17.5, what is the more effective way to do that?
Multiply it by 4?
Yeah, multiply by 4, because I have 4 of them. Okay, so 17.5 times 4 plus 25. So 17.5 times 4. So 5 times 4 is 20. Carry the 2. 28 plus 2 is 30.
Sorry.
1 times 4 is 4 plus 3, which is 7. Okay?
Thank you, William.
1 decimal place I'm going to move. So this right here gives me 70. And 70 plus 25 is 95. My unit is inches, so it's inches squared. All right. The turn and talk says, is there another way to solve for the surface area? Can anybody think of another way that we could have done this?
I don't think I can. We could have added 17.54 times.
Right, that would be one of the other ways that I can think of doing it. Okay, so we could, so the formula that I'm teaching my 7th graders is 2 times b plus the perimeter times the height. Let me see, I'm going to go real quick to see what they give you guys on the reference sheet. Because on the reference sheet, you guys kind of have to know what the formulas are. So let me see what they give you. Oh, they are so loud. Okay, so on the reference sheet, they don't even give you surface area. That's weird. Yeah. They don't even give you the formula for surface area. So you are going to have to know how to do this without the formula. Okay? So let's not worry about this one right now because that's a 7th grade rule and I don't want you guys to get confused. Okay? Alright. So we're going to put down what Gia said so we can add 17.5 4 times. That's the only other way I could think of what we would do. Alright, so we are running out of time. So let's move on real quick to the last one. Okay, so we're back to a rectangular prism. Actually, we have 1 minute. Okay, so it says find the area of the right and left faces. So that's this right here. This piece right here. Okay? So that we know is a 4 by 3. So 4 times 3 is 12. Okay? The top is this one here, which is a 7 by 4, which we know is 28. And then the front, which is this right here, is a 7 by 3, which is 21. All right? We know that there are 2 of each one. So this would be a 12, a 21, and a 28. Okay? We will pick up here tomorrow. Start here, and tomorrow is the 24th. That way I remember. Okay? All right, guys, you have a great day, and we will work on the check understanding and on your own tomorrow, okay? All right, see you tomorrow.
Bye.
Bye-bye.
Bye, Miss Lavelle.
See you tomorrow.